Hi everyone. In this particular video, I will explain you what is linked list and how we can implement using Python programming. So let's discuss it. What is linked list? So basically, uh, in Python we have list. Okay, there is an inbuilt data structure in Python programming list. So basically, list is a array kind of implementation. Okay, so whenever I say array kind of implementation, so there will be some, okay, there will be indexing, okay, like 0 1 2 3. So if I will fill element, let's suppose the element is a b c and d, and if I will ask that print d, so it is easy to print here because you can access it directly using the indexes. Okay, so if you want to access something very fast, so list will help you. So when you are implementing a function and in that function you want to access something very fast, okay, using indexes, so list will help you. But linked list is a just opposite of it. Okay, what is this, like what is linked list? Let me explain you now. So basically linked list is a data structure. It's a linear data structure that contain or that consists sequence of nodes. Okay, and what do you mean by this thing? So there will be one node and every node will have two information. One will be the data and other will be the address of the next node basically. Okay, so here will be the address of the next node. Let's understand it with the example. Let's suppose we have some element 5 3 4 2 and 1, and now we are going to store this element into the linked list. How we can do it? So we have to create 1 2 3 4 and 5 node basically. So we need node. Okay, so every node will contain two information. One will be the data, other will be the address of next node. Okay, so here I am putting 5. So let's suppose, okay, here I am putting 3. Okay, and then this box is I'm lefting here because this will contain the address of the next node basically. So now let me plot one more node, and here let me 4, and other will be uh, 2, and last let me put it 1. Okay, so now for each boxes, so let's, because now you can see it, if you want to store one element you need two addresses, so that is a disadvantage of linked list again. Okay, so because this will increase the space in memory. So if one is space taking 2 bytes, so this will be take 4 byte, but in the list this is not going to happen. So in the list what is happening, every element is just taking only one thing, okay, that is data. But here you are storing one more extra space, that is what, address of next node. So let's suppose this is a 201 to 202. Okay, this is a 203 to 204, and this is a 205 to 206, 207 to 208. I'm just giving the address. Okay, this is not actual address, just to explain thing I'm just giving the random address. So here if this node will point to the next node, let's suppose this one, so here this will be the number 205. That means what, this node is pointing to this node. Okay, uh okay, so let's suppose 209, let me just write everything here. Okay, so 14 15 16 10 19. So now let's suppose this node is pointing to some other node. So here let's suppose the address is 209, so it will point to this location. And here if I'm saying that 17 217, so it will point to this one actually. And okay, so I hope you're getting my point. And if here I'm mentioning 15, so this will point to this one. And if I'm not mentioning anything here, so this will be the end of the linked list basically. So in the linked list we have two things. One is starting one. uh, okay, so this is first node basically. So how to access this first node? For to access those that first node, we have to again create one head node. Okay, so head node basically will contain the address of first node. Okay, so it will contain 201. So by this you can access it. And the last one basically known as a tail of the linked list. So this is a very simple example of okay. So basically now you'll ask that you are explaining this thing, but I'm not getting the point, like why we need a linked list basically. Because list is doing the same thing. Okay, you are correct. So basically, if you want to do some insertion operation or delete operation, so linked list will be more sufficient as compared to the sorry, linked list will be more efficient basically as compared to the your list basically. So list is only help you if you want to access something very fast. Okay, like in that case linked list is not good, but generally if you ask, linked list will help you to do operation like a delete operation, insert operation. So for an example, you want to remove this element. Okay, if you want to remove this, what you have to do, you have to just modify the address. Are you getting my point? And pointing to the some other location. But in the list, what is happening, if you want to delete it, suppose middle element 4, so you have to shift all the element back. Are you getting my point? So there are two operation. One will be the, like, one thing where you have to write the code for delete and then shifting the element one by one. Here that is not a case. You just need to modify the address. Okay, if you want to remove it, just you can drop it. Okay, are you getting my point? So there is not a lot of operation you are going to perform over here. Okay, so what is the one take point from here? So if you have a list, so list is very useful if you want to access something very fast. Linked list will be very useful if you have some kind of function where you are deleting or removing the element in the middle of your element basically. Okay, like here 5342, and if you want to remove 4 or if you want to remove 3, okay, so you have to, in that case linked list will help you. Okay, so enough theory, let's implement this thing, then you will understand. So what we need to implement here, so think now, like before writing code we need to think what we need. So basically we have to create node. Okay, and every node have two information. One will be the data and other will be the next where my node will point out actually. So there will be two information with respect to the each node. One will be the data, other will be the next address basically. Okay, so uh, you got my point. So like list, so if you're following my data structure videos, uh, every data structure associated with some operations. Okay, like in the list we can add, we can insert, delete. Okay, similarly in the linked list we can add, we can insert, we can delete. Okay, we can update the value also. Okay, so we can do various things. So first we will implement how to implement node, and then on top of the node how you can add a new node and we can assign the address. Okay, we will do that operation. We will also see how we can remove the element or delete the element. Okay, uh, okay, so let's implement it. Okay, so just to save time, okay, what I will do, I've already written the code. I will paste over here and I will explain each block one by one. Okay, so the very first thing what we need a node, and we know that in this node we need two information. One will be the data and other will be the uh, like reference point where like we'll store the address. So here in this class, okay, so we created two instance variable over here. Okay, one is a element which store the value of the element, okay, like this, and the next which is reference to the next node in this list. Okay, you got my point. So using this code we can generate or we can create our node. Okay, so now let's implement the next block. Uh, okay, so I implemented one more function called linked list. So here we have some instance head and size. So let me explain this piece of code and then we'll move further. So basically what we're doing, so if you have node, so to access that node, so basically we need a head. Okay, so uh, there will be the head. So initially it is not pointing anywhere, let's suppose. Okay, it is not pointing anywhere. And how you know that, like how many element you have in the linked list? Okay, are you getting my point? Why we need like why we require this kind of information? To understand, like the thing that uh, like our linked list is empty or not. Okay, for an example, if there is no element. Okay, okay, so how we can know that? Okay, so for that reason we are declaring one more variable, size. So size will tell you that how many element you have in the linked list basically. So we are also written one more function to check that our linked list is empty or not. Okay, so here I'm checking that one. So it is returning true and false. Based on that you are doing the operation. So the very first method, and you know that on the linked list we have various operations basically, like we can add the element, we can remove the element, we can do lots of things over here actually. So the very first operation which we are doing here, how we can add our first node. Okay, so basically if you want to add your first node, basically you are creating a linked list. Okay, so first you have to create your node. So to create the node you have to call the method, like you have to call the class method. Okay, so basically you are calling the class method and you are passing the element, because that node will contain two information. One will be the are you getting my point? One will be your element and other will be the address of the next block. Are you getting my point? Okay, so this the first line will give you the new node basically. And the new node, the first address, let's suppose is a 200, that I will store somewhere. So where I'm going to store it? We are going to store it in our head variable. Okay, so here we have head. Okay, so initially it is a none. Now I will assign to the first address of this node actually. So this will now, and then also we will increment the size, because now in the space we have this, like now linked list size has been increased. Earlier it was 0, that means there was no linked list. Now as I created one node and then I assign head, and so that I will also increase my size by 1. Okay, so this is a code. Understood? Now next question. So this is very simple, this is not very hard. Okay, so in interview they can ask that what, like the question will be very straightforward. What is linked list? Explain it. So you can explain theoretically, and then you can tell why we need linked list, and then you can tell how you can implement it. Okay, so first you have to like if you can implement it. Okay, so that is more than enough to understand, like you know the linked list. And then we need to, like they can ask the various operation how you'll implement this thing using the linked list. So this is very first question. They can ask like how you can add linked list. Okay, so how you can add node at the first location. Okay, now this is not a first location. Okay, I am adding first node. So now next question, how you can add the last element at the last. Basically what I'm trying to do here in this code. So if you have linked list, okay, so think just to make think easy, I'm taking only 3 node over here. Okay, so let's suppose we have 5, 4, 3. Okay, and let me connect it. Okay, so 202 or 204. I'm just going with the event number 206, 208, 2010, 2012. Okay, so here we have 206. Here we have, because this node will contain the address of the next block, so it will be 2010. So our question is that we have to add one node basically. Okay, one node at the end. So basically currently at this one. So if you see, let's suppose this is our current linked list. Okay, so this, like there will be head. So head will point at somewhere. Okay, might be head is pointing here. Okay, we don't know, might be head is pointing here. Okay, so if head is pointing to this location, that means what? This will be your first element into the linked list basically. Are you getting my point? So now this last one is, there is no address. That means what? This is the end of list. That means what? This is a tail of your list basically. So uh, what you will do here, at the last you are going to add. So it's very easy. So basically what you're trying to do, so very first step what, you will create the node. And how you can create the node? You have the code over here. Okay, you have this code. Okay, this you have to call this class, and here you have to pass two instances here, one with the element and then other will be the at what location it will go. So here what we are doing actually, we are creating the node. Sorry, I'm really sorry, I'm referring the wrong code. Okay, just a minute. So here we are creating the node, and then so now we have a node. Okay, node we have ready, but before adding it, we are checking some content. This is called boundary cases. Like first we are checking that if linked list is already empty. Okay, are you getting my point? If linked list is already empty, that means what? Our last element will be the first element. So that means what? This code will, the code will be very same. Are you getting my point? So we are doing the same thing actually. So we are assigning the new node to the head actually. That is what, that is our first element. If that is not true, what we're doing actually? So very first step, what we're doing, we are uh, we are storing the value of head actually. That means what? We are trying to find out that where our where my head is pointing basically, that address I'm storing it. Why you need to store it? Because you want end address, like you want a last address, so that at the last you can add it. So basically you store at current one, and then what you are doing, you are moving one by one till at what point you are moving, at like you are going next node and next node, and you are doing the same thing. Once you get the, like, if there is no address available, okay, that means what? There is no next is available. That means what? That is your tail basically. If somehow you can get that things, so you have to store that thing into your current one. Are you getting my point? So like, and then you have to let's suppose 2014 is the address. So you have to it changes to 214. Now it is pointing to here, and then you have to increase the size by 1 because you have added one more node over here. Understood? This code is very simple basically. So the very first step, they are creating the node, and then after creating the node, they are checking the one thing, like if node is already empty, so you can think like a, there is no linked list, so you have to assign that node as a first node. Otherwise what you're doing basically, you're doing things like you are iterating, like if your head is here, you are going till at what point? Once you get your tail, at the tail you are assigning the address of your new node. Okay, and then you are updating the size, and this is a case. Understood? I hope you got my point. Okay, and if you want to this thing, okay, remove first. Okay, so like I'm I'm not going to explain it. Okay, so I'm leaving to you so you can understand. It's not very hard. Okay, so basically what if you want to remove very first element, how? It's very easy, no? So if you have, let's suppose, three element, if this is your head, it is pointing like here. Okay, let me, so if you want to do, so what basically you have the very first thing, like this head will pass, head will point to this point to the this node, and you have to remove this link. So basically now list will only contain the two elements. You have to also decrease your size of linked list like this. So what you're doing, so very first step, you are taking the where is your head, and then moving it, and you are moving to the next one. So now head is pointing to this basically, and then you are decrementing your size basically. Okay, understood. So hope you got my point, like how you can implement linked list in the Python one. So there is more operation, like you can find out the question also. Okay, like how you can delete element in the middle of your linked list. That could be another question. So there could be lots of question, but the basic idea is very simple. At the end, what matter more, uh, we need to understand how that particular data structure is working. So basically linked list is a kind of like it's a sequences of node where every node will contain two information. One will be the like what data it will contain, other will be the like what will be the next address or next node basically. So in short, we can say like this: a linked list is a linear data structure that consists of a sequence of nodes where each node store the reference to an element and a reference to the next node in the in the sequences. Okay, so basically there are head and tail. Understood? Okay, so so this code will be available on GitHub. So yeah, you can refer. The link is available in the description, so you can get it. Okay. Okay. Thank you.